Hello, this lecture is Unit 4, Standard 2. In this particular section, we're building upon the last lecture where we talked about relative maximum and minimums. This particular section, we're talking about absolute minimum and maximum. So we're trying to figure out in the whole function, where is the absolute minimum and where is the absolute maximum. In the last lecture, we just talked about where is there a local minimum and where is there a local maximum. But we want to know where is the biggest or smallest value in the whole function. So first of all, you have to have, or this is the theory, if f is continuous on a closed interval, okay, remember we talked about continuity, if it's continuous in interval, then it must have an absolute maximum and an absolute minimum. So if you have a closed interval and it's continuous, then there has to be an absolute max or an absolute min. Here's how you do it. First, like we did, the first couple of steps are very similar. First, you find the critical numbers. Remember, you take the first derivative and set it equal to 0. Then you're going to use the first derivative test. Remember, we put the numbers, the critical numbers, on a number line, and we tested to find the intervals where it's increasing or decreasing. And then when you find what's increasing and decreasing, you can figure out where you have a local min and a local max. So determine the x values where the maximum could occur, and also the endpoint. So the maximum and minimum can either occur at the local min and max, or it could be at the endpoints. Okay. And then you plug the x values into the original function. So let me highlight that in red. Once you find out these numbers, the relative mins and maxes and the endpoints, you have to put it in the original function. Okay. So again, I'm going to put this in red so you guys understand the original functions where you put these numbers in. Then you could do the same thing. This one just means the same thing, but to do it for the minimum. And then plug it into the original function again to find the minimum value. So it's just one more extra piece to what we just learned on the last lecture. So for example, let's just say, for example, obviously it's really easy if they give you a graph. Okay. So if I look at this first one on the left, it says find the absolute extrema from -2 to 5. Well, if I'm only looking at -2 to 5, I'm only looking at this section right here. Okay. I'm only looking at that section here. Now, if I'm looking for absolute extrema, and they give me a graph, I don't have to do all the steps that I talked about. Okay, all I have to do is just really look, where's the absolute minimum, absolute maximum. First of all, I have to see if the theory holds true. Is this continuous and is this a closed interval? Well, yes, it's a closed interval because I see that right there, and yes, it's continuous. There's no gaps, there's no jumps. It's one continuous line. If I'm trying to find the absolute max, I see where's the highest point in this graph. I see the highest point is here and here. There are actually two absolute maxes where they hit the exact same. And that occurs at -1 and at 5. So if I scroll down here, it says what is the absolute maximum value? The absolute maximum value is 4. The highest this reaches is 4. And this occurs at x equals -1 and x equals -5, or x equals 5. Okay. If I want the absolute minimum, again, I'm going to look at where the lowest point is in the highlighted part. The lowest point is here. That's -4, and that occurs at x equals 3. Okay. Just so you can see another example of this, this problem says, what about the absolute extrema from -5 to 5? So I'm going to highlight from -5 all the way to 5. Okay. 5 goes all the way down there. All right. So now let's start with, for something new, let's start with minimum first. The minimum part in the graph, you may notice in the part that I highlighted, the minimum point goes all the way down here. Okay. All the way down here. You'll notice that it hits, just for the sake of this picture, I know it's hard to see, but the lowest point it ever hits is -16, and that occurs at 5. So I'm going to write -16 at x equals 5. The maximum, a little bit more different, you'll notice that the maximum is up here. It hits a maximum height of 7, and this occurs at 2. So what is different about this particular problem? Well, you'll notice that at these two problems, the maximum and minimums can occur either at local mins and max. So if I use another color, this was a local max, right? But it wasn't the only absolute one. This was also absolute. This one was not a local min or max, but it was an endpoint. So again, the absolute min or max can occur at a local min and max, or at an endpoint. In the second example, you'll see that the absolute max occurred at a local max, but the absolute min occurred at an endpoint. So just keep that in mind, that it can be at a local min or max or an endpoint. So I'm going to look at this one. This one is an example in which the problem does not give us a graph, and we have to solve this algebraically, and we're going to do this just like we did in the last lecture. So if I look at this, I see that I have a function, and I want to find the max and min. So the very first thing I'm going to do is I'm going to do all the steps to find out where the local mins and maxes are. So the first step we did was we took the first derivative, which was 2x to the third minus 8x, okay, using the power rule. And then I set that equal to 0. After setting it equal to 0, I'm going to solve for x. So I could factor out a 2x. I get x squared minus 4. That x squared minus 4 can be factored into x plus 2 and x minus 2. Okay. That gives me, if it's equal to 0, this gives me 3 critical numbers: 0, -2, and 2. Okay. And now, again, I'm going to put this on a number line, like so, putting it in order. And then I'm going to test some numbers. I want to test -3, -1, 1, and 3. And I want to just see what the signs are. I don't care what the number is or what values I get. I just care about what the sign is. If I take -3 and plug it into here, I'm going to get a negative, a negative, and a negative. This whole segment here is negative, because a negative times a negative times a negative is a negative. If I plug -1 into here, I get a negative, I get a positive, and I get a negative. That means this whole segment is positive. If I plug in 1, I'm going to get positive, positive, and negative. That means this whole segment is negative. And if I plug in a 3, I'm going to get positive, positive, positive. This whole segment is positive. So this tells me that the possible min, or in this first, at -2, right? I'm looking at -2. I go from negative to positive, okay? So I'm going from negative to positive, which means at -2, I have a min. At 0, I go from positive to negative, which means I get a max. And at 2, I go from negative to positive, I have a min. So now what I've determined is that the local min is at -2 and 2, and the max occurs at 0. But the question asks, what's the absolute min and what's the absolute max? So let's look at the possibilities. My max could occur at 0, which we found, or at the endpoints. If I look at the very original problem, my endpoints were -3 and 1. So I could test -3 and 1. Okay. Now, to figure out which one is the absolute, which one is the most highest value of these 3 numbers, all I do, like I said in the steps, is take these numbers, and plug them into the original function and see which one gives me the highest number. If I plug in 0, I'm going to get 0. Okay. If I plug in -3, and what I'm going to do is I'm going to use a website. It's called Wolfram Alpha, or you can plug it into your calculators. It's good for you to practice on your calculators anyway. In Wolfram Alpha, what I'm going to do is I'm going to plug in the formula, which I already did. So again, it's wolframalpha.com. I plug in the formula, half x to the 4th minus 4x squared. I'll say when x equals -3. And if I plug in -3, I get 9 over 2. So if I go back to my problem here, I get 9 over 2. And then I'll go back to my calculator again, and I'll try calculating this when it equals 1. And I get -7 over 2. So going back to the problem, so I plugged in 0, I plugged in -3, and 1 in the original problem. Here are the numbers I get. So of these 3 numbers, which one of these is the biggest? Well, this one's the biggest. So that tells me the absolute max is 9 over 2 at x equals negative 3. That is the absolute highest this function ever gets in that closed interval. Now let's try min. Min, if you remember, when I did the intervals, I had two mins, or local mins, negative 2 and 2. And then I also have my two endpoints, which are negative 3 and 1. And remember, we already solved negative 3 and 1. So I'm going to put negative 3 gives me 9 over 2. I already know that 1 gives me negative 7 over 2. What I'm going to do now is take these other local mins, put it in the original function, and see which one gives me the smallest number. Again, I'm going to go into my calculator. I'll plug in negative 2. Oh, which reminds me, this interval, let me show you. This interval is negative 3 to 1, correct? Well, one of the numbers that we found was 2. That tells me that 2 cannot be the absolute min because 2 isn't even in the interval. So again, just to repeat that, the problem says what's the absolute minimum from negative 3 to 1. One of our possibilities was 2, which is not even in the interval, so I'm not even going to test 2. Okay. So now let me go back to my calculator and plug in negative 2, and let's see what we get. We get negative 8. Okay. So I'll go back to my notebook, and I get negative 8. Negative 8, right? Yeah, negative 8. Now, out of all these numbers, you'll notice that the smallest number that I get now is negative 8. So that tells me that the absolute min is negative 8 at x equals negative 2. So that's all there is to absolute max and min. So just to review, this will be the only example I give you for today. I'm going to do the exact same steps that I did for local min and max. So what I did was I took my function and took the derivative. I factored it, set it equal to 0, and solved for the critical numbers, which in this problem were 0, negative 2, and 2. I took those numbers and put it on a number line. After putting it in a number line, I tested numbers to see what was the sign of the four intervals. Well, I found that this interval is negative, this one positive, negative, and positive, which told me that going from negative to positive, I have a min here, and a max at 0. After taking these numbers, or after finding these numbers, I took the mins and maxes, and I also combined it with my endpoints. Again, my endpoints were negative 3 and 1, and I plugged them all into the original function to see which one, when I plug it in, gives me the highest or the lowest numbers. I put it into a calculator, and I found that when I plug in negative 3, I get my highest number, which is 9 over 2, and if I plug in negative 2, I get my lowest number, which is negative 8. And that is how I find my absolute max and my absolute min. So hopefully y'all understand this. Again, what I'm going to ask of you is to do a couple practice problems and then do a video, so I understand that you understand. So thank you for watching the video, and have a good day.